Right. As we have completed that single linked list, today I'll explain the main concepts of double linked list, but remaining complete code you have to develop just with the knowledge of your single linked list. Okay. See, double linked list means what? Node representation like this. It has 3 fields, not 2 fields. The middle one, suppose if you take the data field, just physical representation is that. Not exactly middle, but physical representation like this. Physical representation. How the values will store? It is holding the left side link, it is data, and it is holding the right side link. Right side. Suppose if you create the nodes, nodes will be like this. The nodes will be like this. Suppose is a node list. We are creating the list. Is a first node, is a second node, is a third node, third node. First node addresses also we are representing. Suppose 1000, 2000, 2000, and 3000 and 3000. And the data. First node left link is null because there is no left connection. Suppose 10 data. Right side node is there. So 2000, 2000. It is pointing to this node. And here it is left side connection is there is 1000. 20 for this right side connection is there 3000. So it is pointing to this, and is a left side connection is there 2000, 30, and this one is a null. For these two actually left connection is there, and this one is also connection is there like this. See, first node left side link is null because there is no left side connection. Right link, I mean last node right link is not there, that is also null. This is actually simply the representation. Is a root node is always pointing to that starting node that you know already. But anyway, two connections you need to do. Two connections, always two connections you have to do. Only few things I'll explain. Remaining things you only complete. Okay. First one, suppose root is 1000, consider. Add first. I'm writing the code for add first. So creating the node. Creating the node. Initially, sir, how can you represent the class node? One is a data. One is a data. Second one is a left link. Third one is a right link. Just node left and right also you can write. Okay, now I'm just representing like this simply. Whenever you are creating object for this, node will be created 4000. Suppose that you are collecting into one temp variable. Temp, store the value, suppose 40 into temp2 data. Now total 3 connections you have to do. Very, very important. Total 3 connections you have to do. This is one connection. This is one connection. And this is second connection. Is a second connection. And this is third connection. So we already know that right side connections first. Right side connections first. Simply. So Here you need to store 1000. Here you need to store 1000. Sir, where is 1000? 1000 is nothing but root. 1000 is nothing but root. Value will be stored into temp2 link. Will be stored into temp2 link. Please observe this one. Okay. Into temp2 link. Into temp2 link. Root value will be stored. Root value will be stored. Now, this 4000 you have to store here. But very, very important. Sir, suppose if node is not there, consider that is null. Na? So if root is not equal to null, if already node is there, then that root to left, sorry, my mistake. This is not link left, right. Na? Is very, very important. Right. Right. Okay. Just root to left. Left is equal to temp. But this point is important. Blindly, suppose if you try to store temp value into root to left, consider, imagine if it is not there. Root is null. First time only you have called add first. Then null to left will not be there. Na? You will get that null pointer exception. So root to left is equal to temp only if root is not null. So two connections completed. This is one connection. This is the first connection. That is this one. And this is the second connection. Is the second one. Third connection is what? This 4000 you have to place in root. Easy. 4000 you have to place is a 3 into the root. Temp will store. Into the root, temp will store. This is the one. It's a third one. Take the screenshot. I'll explain add after. Everybody. Right. Okay. Now the concept of add after. The concept of add after. Suppose here I just want to add the node here. Now I'm writing that code. Let me remove this because for new connections you will understand more clearly. Now suppose if location is valid, first we just move the control to this location using one variable. Suppose target variable. Target is 2000. So you need to connect the node here. You need to connect the node here. Suppose here is a new node, is a 4000, and the value is a 40, and this one into temp 4000. As of now, it is there. Now, actually, how many connections are there? How many connections? Total 4 connections. Left side 2 connections. Right side is a 2 connections. These are left side connection. Okay. Next 2 more connections right side. But you know already, right side connections only first. Right side connections first. Because suppose if you give left side connections first, then we lost right side links. Sorry. Like this, connections are required. Temp value is a 4000. Temp value is 4000. Now I'm doing this one. First, observe this. This is important. First, this connection I want to do. First one. What is this? 3000. This 3000 you need to place here. Yes or no? Yes. 3000 you need to place here. Observe. Sir, where is 3000? Where is 3000? Here. Sir, what is this? Target to right. What is this? Target to right. The target to right value will be stored into temp to right. That is the first connection. Into temp to right, you are storing target to right. Target to right means this 3000. First connection done. Second connection, in place of this 2000, you have to place this 4000. This is also important. 4000 you need to place here. Sir, 4000 means? 4000 means temp. 4000 means temp. But where you have to place? Where you have to place? Target is 2000. 2000 to right is 3000. 3000 to previous. 3000 to previous. Target to right. Target 2000. Target to right is 3000. 3000 to left is location. In that location, temp value should store. Again, I'm explaining. Target is 2000. 2000 to right is 3000. 3000 to left is the location. Into that location, 4000 you have to place. 4000 means what? Temp. 4000 means temp. This one you need to do. That is the second one. Then right side connections completed. Right side connections completed. Now come to the left side connections. It's very easy. 2000 you need to store here. 2000 means what? Target. Store into temp to left. Temp to left is equal to target. Target, that is 3. Here it is 2000 will store. So it is connecting. It's a third one. It's a third one. Next one is a fourth one. Fourth one is this 4000 you need to store here. This 4000 you need to store here. Sir, what is 4000? Temp. Temp you need to store into target to right. target to right is equal to temp. Right equal to temp4. Sir, one question is there. Sir, add after you have written okay. But sir, suppose in case if this node is not there. If this node is not there, just imagine. Then how can you put 4,000 here in this location? Yes or no? Suppose consider this is the last node. We are adding at the last end only. Only one simple thing you need to do. Suppose 3,000 is okay, because if it is the last node here, null will be there. Like that, null will come and store here. Only problem is with this one. Nothing but this one is the second one. So when you have to do the second one, if target to right is not equal to null, this one you have to do. If the target to right is not equal to null, then only you need to do this one. Else this is not required. Else this is not required. This is the code for add after. By taking the location, you know already how to take the location, right? How to specify that length and everything you need to check. This is add after. So today your concept is take the screenshot of this one. My requirement is append you have to write. Add first you have to write. Display, traverse you have to write. Length you have to write. Swap you can write. If you can able to do delete and delete first also, delete first and delete after also, you have to complete double linked list code you have to drop in the chat box. Inside the, in WhatsApp group, everybody has to drop double linked list concept. Then in tomorrow class, directly I will start binary search tree explanation. Please complete this, everyone. You can leave. Take the screenshot and leave.